All right, hello and welcome to our presentation on secondary succession in Point Pleasant Park, also known as M2 Kati, following Hurricane Juan in 2003. Okay, let's get into this. So it's important for us to actually understand what it is we're looking for in this lab and to recognize those variables. We are focusing on an area disturbed by a hurricane, Hurricane Juan specifically, which the disturbance effects are removing tree canopy cover and disturbing understory vegetation alongside succession, which we divide that into two categories. We have primary succession, which refers to the geologic change of existing substrate or the creation of entirely new substrate, often seen with volcanoes and such. And then we have the secondary succession, which is what we see here, which involves disturbances that do not cover, remove, or create new substrate. And again, this is just kind of to reiterate that we know what kind of succession we're looking at. Overall, the understanding of the effects in disturbance is critical for progression and restoration. Hurricane Juan made landfall on September 29, 2003 as a Category 2 hurricane, destroying much of Point Pleasant Park with an estimated 70% loss of the park's canopy cover. Point Pleasant Park lies within Kachipajuk, the unceded territory of the Mi'kmaq people, and the park specifically is known as Amtukati, holding cultural significance as a gathering place. It's also an urban park located in Halifax, Nova Scotia. Biodiversity-wise, it's a mixed Acadian forest type dominated by mature softwood prior to 2003. This was predominantly red spruce and white pine, followed by hardwoods such as red maple, white birch, and red oak.
Okay, so our objectives of doing this project are to understand the effects of Hurricane Juan on Point Pleasant Park and how its secondary succession has progressed by looking at data collected from 6 different sites in the park from 2004 to 2005. We also want to determine how the overall community has changed, how the density of dominant species in 2004 and 2005 have changed, and how the chosen community metric has changed over time following the disturbance. Finally, we want to predict what will happen to these variables as the forest moves towards its climax community. Our hypotheses are that the diversity of the community will have increased, red spruce will gradually replace red maple as the dominant species, and that the diversity of Point Pleasant Park will decrease as the forest approaches its climax community.
Now, let's move on to our methods. Within lab, groups were assigned to 6 sites within the most damaged areas of Point Pleasant Park. Random quadrants were selected for sampling, which included throwing an object and recording the area in which it landed. Half of the group measured trees via trunk circumference, and the other measured a 50 by 50 centimeter area in regard to vegetation and abiotic cover, noting the estimate percent cover and species. All data was then combined and further analyzed using the Shannon-Weiner Index and Pelu's Evenness Index, which is the data you see used within this presentation.
Okay, so starting off our results and discussion, we're looking at changes in overall forest community. We used the Shannon's Diversity Index to determine how the forest community has changed from 2004 to 2005 as Point Pleasant Park recovers from the Hurricane Juan disturbance so that we can understand the progression of the ecological succession in the area. So Shannon's diversity, or H prime, is an index that incorporates both species richness and species evenness in its measure of community diversity. As you can see from the figure, our results show that from 2004 to 2005, H prime increased from approximately 0.5 to 1.5, showing a 200% increase in overall community diversity over time. This supports our hypothesis and is consistent with findings that species diversity increases following a disturbance as more resources become available, which creates greater ecosystem heterogeneity as more species establish. We predict that as the secondary succession in Point Pleasant Park continues, the species diversity will continue to increase, but the rate will slow or decline as the forest continues to move towards its climax community. This is because of things like competition, eliminating species that initially colonized the area following the disturbance. And some studies have found similar things, like, for example, Pratch et al. 2021 found that forest diversity peaked after roughly 40 years of succession, then it declined before rising again.
So we were interested in how the dominant species density has changed over time. In 2004, Point Pleasant Park was in its early succession stage. Pioneer and early successional hardwoods like the red maple and birch started establishing. The red maple establishes quickly in post-disturbance conditions when there's an abundance of light and canopy space, Burley et al. 2008. We see the density of the red maple is much higher in 2025, and it is still increasing, which, in addition to the continual rise in diversity, tells us that we're not quite in the late successional stage. The red spruce density has gradually increased over time because it is a late successional shade-tolerant species that reestablishes in the understory. It's Keyes 2018. Because of this, the red spruce will likely continue to grow in density and become the dominant species in the future as the late-stage successional climax species, and it's Neely et al. 2004. Okay, so here we are looking at two graphs that show us how the densities of red maple and red spruce have changed in Point Pleasant from 2004 to 2025. Right after Hurricane Juan, the red maple increased sharply. This makes sense because the storm opened up the canopy, creating a highlight condition that the red maple thrives in. It's a classic early to mid-successional species that grows quickly and takes advantage of disturbance. It's Burley et al. 2008. In contrast, the graph on the right shows the red spruce, and the red spruce increases much slower. It does not show the same spike early on. Instead, the trend is gradual and is steady. The red spruce is a shade-tolerant late successional species, so it doesn't dominate right after a disturbance. Instead, it slowly builds up in the understory, Keyes 2018, and becomes more abundant as the canopy begins to close. So together, these trends tell us that the forest is transitioning from mid-succession towards late succession. The red maple has dominated the first part of the recovery of Point Pleasant Park, but as the shade levels continue to increase, the red spruce is starting to reestablish. If these trends continue, the red spruce is expected to eventually replace the red maple as the dominant canopy species, returning the park towards its pre-disturbance Acadian forest structure, Neely et al. 2004.
So our changes in chosen community metrics over time have been seen through early, mid, and predicted late successional growth. Early on, it was barren with a clean slate for secondary succession. Following Hurricane Juan, most old growth trees were destroyed. It was pretty bare. Mid-succession, which is current, shows the vegetation recovery with a decreasing evenness as red maple becomes increasingly dominant. Red spruce is still increasing, but is obviously less abundant. The predicted outcomes within late succession is a decrease in diversity and a lower species evenness as red maple and pine will likely dominate as it approaches the climax community. And here we just have a graph to better visualize the data explained in the previous slide, which shows this linear path of richness increasing and then a decrease in the evenness. The odd dips are likely due to smaller scale disturbances, such as droughts seen, over the summer, and human interference or disturbance.
So in conclusion, Point Pleasant Park has undergone secondary succession following the disturbance of Hurricane Juan. It is likely that it is in a mid-successional stage. The red maple is a mid-successional species, which grew rapidly early on in the park succession due to its preference for the highlight environment. But slowly it's being replaced by the red spruce, which is a late successional species, and all of this suggests that the park is transitioning to a mature forest state. Community diversity of the park is still increasing, but will likely plateau or decline as it begins to approach its climax community. Species richness is still increasing as well, but evenness is beginning to decrease, supporting the prediction that diversity will decline as the forest continues to mature. And since Point Pleasant Park is an urban park, it may move through the stages of succession a little bit differently than a remote forest would. And this is because of increased human disturbance as people use the park for walking, biking, and other leisure activities. This can cause a different kind of disturbance than you would see in a natural forest. And given its urban location, Point Pleasant Park is also susceptible to non-native invasive species like the Norway maple. And debris removal and cleanup also takes away woody material like dead or dying trees that would otherwise provide nutrients into the soil and removes it from the ecosystem.
Two-eyed seeing, or Edawaptamunk, is a guiding principle that covers all aspects of our lives, including social, economic, and environmental aspects, and it's based on how you should live while you're on Earth and our responsibilities to preserve nature for future generations. It involves combining both Indigenous knowledge and Western science in conservation and management efforts, and this approach can be used to effectively assist Point Pleasant Park's recovery by using the strengths of both. Using two-eyed seeing alongside ecology encourages us to view the forest as a natural cycle of disturbance and regrowth and not just as something to restore to a past state.